you ever seen a helicopter or drone and wondered what allows these amazing machines to fly? The answer lies in the physics of aerodynamics and the elements of stability and controllability.
The lift equation governs the physics of aerial flight. The equation is the coefficient of lift times the density times the velocity squared divided by 2 times surface area.
Note that with velocity squared, even a small change in speed will have a large effect on lift.
Now that equation may seem complex, but let's break it down. Do you think that had lift? Now which of these objects do you think have lift? In reality, the principles of lift are acting on all of these objects. It's just the best flying objects have airfoils.
As air moves over the top of an airfoil, a low pressure area is created, similar to a vacuum. So essentially, an airfoil is being lifted due to a pressure differential relative to the higher pressure below the airfoil. This is a Venturi tube, which helps us understand how airfoils work. The air particles traveling through the restricted area in the tube increase in velocity, which decreases the pressure in that part of the tube. A Venturi tube also demonstrates the movement of air around an airfoil. So we know a drone generates lift through the airflow of the rotor blades, but how does it remain stable? Based on the design of a drone, it has a negative static stability, which means it tends to not stay in one place, like in this example. This is overcome through opposing rotational directions of the adjacent rotor discs, along with the help from the gyroscope making hovering possible. So the aircraft flies, it remains stable, but how do you control this amazing piece of plastic?
All flying objects rotate around the three axes of movement: pitch, up and down; roll, rolling side to side; and yaw, rotating left and right.
Micro adjustments in roll and yaw are created by varying the relative velocity of the four paired sides of the drone.
The flight factors of a drone ultimately come down to the lift equation, the design of the airfoil, and how well it can remain stable and controllable using its four rotor discs. So next time you're applying for a job at NASA, you'll be guaranteed a job at giving people a tour of the physics of helicopters and drones. Thanks for watching.